Hi, hello everyone. In your graphing notebook that you hopefully got, put today's date. This is our first unit on functions. This is day 1 of our function unit. Today we're going to be learning about when relations are functions and then performing all kinds of operations, add, subtract, multiplying with functions also. Alright, to get started, I'd like you to draw arrows from the teacher to the subject that they teach. So pause the video, go ahead, put this in your notebook and do that. Alright, once you've done that, hopefully you have the same thing as me. My question is this lovely thing a relation? Well, what is a relation? A relation is a set that has an input and an output. And an input of a relation is the domain. Your input is the domain. That's your X values. Here it's just the names of the teachers. Our range is our output, or our Y values. And these Y values are the subjects that the teachers teach. Alright, so let's talk about how you could show a relation. So the one that I just had there with the teachers with the subjects is called an arrow map. That's one way. The second way is if I show it as an ordered pair with an X comma Y. The next one is if I put it in a table. And the last one is showing the points as a graph. Alright, so this next concept is real important. How do I know when a relation is an actual function? So when each element of the domain, your X, your input values, has exactly one element in the range, my output. So basically, when they show you the relation, whichever way they show you, those 4 ways, the domain cannot repeat. If the domain repeats, then it's not a function. So let's take a look at some examples. All right, here we have a relation shown as a way in ordered pairs. 1, 4, 2, 5, 3, 6, 4, 7. Well, what is the domain? The domain is your X values, your input. So my domain I would list as 1, 2, 3, and 4. My range is my Y values, my output. That would be 4, 5, 6, and 7. They're asking now the question, is this relation a function? And remember, a function, the domain does not repeat. So let's take a look at our domain values. Each of these are appearing only once. So we write yes, a function. All right, take a look at the example below. See if it's a function or not. This one is not a function. And the reason being, the domain does repeat. -2 repeats. What is my domain? It's -2, 0, 1. That's my domain. My range is 4, 5, and 6. All right, let's take a look at some more examples of relations. 1 and 2 are arrow maps. So pause the video, take a look, and tell me if those 2 are functions. All right, for number 1, this is not a function. The 0 is going to -2, and the 0 is also going to 1. So that means the domain, the input, repeats, not a function. Number 2, the arrow map is a function because the domain does not repeat. They're all going to 1 output value. Okay, 3 and 4, these are also relations shown as graphs now. Hopefully from last year, remember about doing a vertical line test to determine if that relation is a function. So if I was to make a vertical line anywhere on this graph, it has to hit the graph only once for it to be a function. So if you notice, I'm putting my line, vertical line going through number 3. It's only hitting it in one spot. So number 3, yes, is a function. Number 4, if I do my vertical line test, it's hitting in 2 spots. So that means nope, not a function. All right, here are 4 more examples. Take a look, get your answers, come back and see if you got them right. All right, here are my answers. Number 2 is not a function because 3 is going to 4 and 3 is also going to 5. So 3 repeats the domain. And in number 3 in the table, this is also not a function because 1 has 2 as a pair and 1 also has 5 as a pair. So the 1, the domain repeats. Okay, now we are representing functions with equations, which you remember also from last year, f of x, g of x. Here I'm telling you that f of x is equal to 2x minus 5, the equation. How would I evaluate this function? I'm asking you to find these three things, f of 3/2, f of 0, f of 5. Well, what do I do with this 3/2, 0, and 5? Those are my domain, my input. So I'm going to plug that in for x. All right, so for the first one there, I'm plugging in 3/2 for x, so it's 2 times 3/2 minus 5. I do my order of operations. 2 times 3/2 is 3, and 3 minus 5 is -2. And then I did the one for 0, and then the one for 5 plugged in. Here are my answers. All right, this is the last notes for today. So here I'm giving you two different functions, f of x and g of x. That's how they're represented. I'm asking you to find lots of different things here. F of 0, f of 1, f of -1, f of negative x. This should say 3 and 4 here. And then 5, 6, and 7. Go ahead and do 1, 2, and 3, and then I'll talk about 4. All right, so be really careful here with f of x. Make sure that you do your exponents first, then your multiplication. So for these beginning parts here, -2 times 1 squared, make sure you do 1 squared first, then multiply it by -2. And the same thing for the -1, make sure you do -1 squared first, then you multiply that by -2. Be careful of your positives and your negatives. Those are the three answers you should get for 1, 2, and 3. All right, for number 4, f of -x. Well, instead of plugging in a number, you're plugging in a letter, a variable. So I'm replacing my x's with -x. So I did that for you here. What do I do first? Same thing, order of operation. I'm going to do -x to the second. So what is -x times -x? That's positive x raised to the second power, multiplying it by the -2, bringing down this -x, minus 1. Can I add anything else together? Are there any like terms? There are not. Remember, like terms have to have the same base and the same power. So this is my answer for number 4. All right, for 5 and 6, I'm taking two functions and I'm adding and subtracting them. So this is your basic algebra stuff from Algebra 1 and Algebra 2. I'm adding f of x plus g of x. All right, I have to combine my like terms. There is no like term for the -2x squared, so it comes down. I've got positive x plus 2x, so that's positive 3x's. Then I have a -1 plus 3, that's positive 2. Here's my final answer for 5. All right, so when we do subtraction, do we remember that our subtraction actually becomes addition, and we change the signs of the thing that we're subtracting? So when I do my subtraction here, the -2x comes down. We have a 1x minus 2x, which is a -1x. I also have a -1 minus a 3, which is -2. Here's my final answer for 6. Oh, my bad. I did that last part wrong there. It's -1 minus 3, because I'm changing the sign of the plus 3. So -1 minus 3 is -4. All right, for the last one here, I'm doing g of x plus h. So I'm plugging in x plus h for the x in the g function. And it's going to say 2 times x plus h plus 3. Well, how can I simplify this even more? Well, I'm going to distribute and carry the 2 inside. So it becomes 2x plus 2h plus 3. There are no like terms to combine, so here is my final answer.